Okay, so we started with exponent rules yesterday. And yesterday we learned that if we multiply two powers that have the same base, what do we do with the exponents? We add them. And if we multiply two terms, I just said the same thing. If we have something that already has an exponent and I raise it to another exponent, what do I do to those? I multiply the exponent. So if they multiply with the same base, we add the exponents. If we take a power of a power, we multiply the exponents. So this section will be dividing with exponents. That's what quotient means. Quotient is the answer to a division problem. So we're going to be dividing with exponents today, and they're going to be set up looking like fractions. So our job is to simplify. And the way we simplify is if they have the same base and one's on the numerator and one's on the denominator and they have the same base, we subtract the exponents. Okay? So the first one, we're going to have 8 to the 10th divided by 8 to the 4th. They both have a base of 8. So we keep the answer with the base of 8. And what is 10 minus 4? So this is 8 to the 6th power. On problem B, those are 5s if you can't tell. 5 to the 4th power times 5 to the 8th power divided by 5 to the 7th. Well, me personally, I like to simplify the numerator and the denominator separately before I start going on top of each other. So that 5 to the 4th power times 5 to the 8th power, what does that get? Right, they're multiplied, so we add them. And then we're dividing by 5 to the 7th power, which means we're going to do what with the exponents? Subtract and get 5 to the what power? 5th power. Any questions about that? Not too bad, is it? All right, the next one looks a little crazy. It's 1 over x to the 4th power times x to the 6th power. Now, okay, y'all, how do we multiply a fraction times a whole number? Put the whole number over 1. And then we multiply across, don't we? So 1 times x to the 6th is what? X to the 6th. Multiplicative identity property. And x to the 4th times 1 is what? When you multiply fractions, you go straight across. And now they're divided, so what do? Subtract, and I get what? X squared. So any questions on those? I want you guys to try these 4 problems. See if you can. I know you can. Change my date. Today's the 8th, not the 7th. Check in with a neighbor when you get them finished. Yeah. It's n to the 5th power. My 5s look like S's all the time. All right, can y'all help me out? X to the 11th divided by x to the 5th is what? Very good. Negative 4 to the 9th divided by negative 4 to the 7th is what? Just curious, what's negative 4 squared equals? Good. A negative squared will be a positive. Number 3, what do you do first on number 3? Multiply the top, which means you add the ends and get n to the what? Over n squared equals what? Raise your hand if you got n to the 7th for the next number 3. And what do you do first on number 4? And multiply across. Get 5 to the 13th over y to the 6th, which reduces to what? Raise your hand if you got right. I can't speak. Raise your hand if you got y to the 7th. Good job. All right, so what they're going to do for the rest of this lesson is combine these properties with some of them what we did yesterday. Y'all, when you see a whole entire fraction in parentheses raised to a power, that means every single thing in the numerator and the denominator gets the exponent. So it's like a power of a power. Okay? So if the whole fraction is in parentheses and there's an exponent, everything in the fraction gets the power. So on D, x gets a third power, y gets a third power. Now, are x and y like bases? They're not the same base, so guess what? That's the answer. So all you had to do on that one was give them both a cube. Okay? So on E, again, the whole fraction is in parentheses, and there's a square on the outside. I'm going to put the negative with the 7 because it's easier to do negatives with the numbers. And then that's over x squared. And when you have a relatively small number like that, go ahead and evaluate it. What's negative 7 squared? So this is 49 over x squared. Any questions about that? All right, problem F starts to get slightly more complicated, but this one's still not really that bad. What does it mean if the whole fraction is in parentheses with the exponent? Everything gets the exponent. And what if they already have an exponent? You multiply them because it's power of a power. Very good. So it's going to be 4 to what power? 4 to what power? No. It's an exponent of 1 right now. Okay. And then x to the 6 over 5 to the 3rd and y to the 3rd. And my variables are different bases, so the only thing I can do to further simplify is to evaluate my numbers. So what is 4 to the 3rd power? 4 times 4 times 4. 64. That's one that has been coming up a lot, isn't it? And what's 5 to the 3rd power? 125. And y'all, if the two numbers will reduce as a fraction, then you reduce them. But there's no number that goes into 64 that goes into 125 besides 1. So this is my final answer. Any questions? All right, now they start multiplying fractions on us. The first thing we want to do is get rid of our parentheses. And how do we get rid of parentheses? Yeah, we give everything the fifth power, right? And if it already has a power, we multiply it. So what is a squared to the fifth power? A to the 10th multiplied. And what's b to the fifth power? B to the fifth power. And we'll copy that other fraction. Then you multiply across. A to the 10th times 1 is a to the 10th. And these don't have any like bases, do they? So I'll just write them together, and I like to do them in alphabetical order. 2a squared b to the fifth. No, it's not. I can simplify one more thing. Yeah, the a's are like bases, and they're on top of each other. That means they're being divided. So what do I do when we divide? Subtract. And when you subtract, the left, I call it the leftover, goes to where the higher exponent is. Okay? So the big kid sitting at the table gets the leftovers. All right? Got it? So that's how I remember it. Big kid gets leftovers. So what is 10 minus 2 for the exponent? 8. So a to the 8th goes on top because the bigger one was on top. And then we have a 2, b to the 5th staying on bottom. You know you're done when you have no like bases and your numbers are simplified. And we don't have anything in the numerator besides a 1, so we're good. So you're done when you have all different bases and your fraction is reduced. The next one's very similar. What do you think we're going to do first? Yeah, fix the parentheses, do your powers. So on that numerator, you're going to have x to what power? 21st over y to the 7th. I don't know why I made that fraction so big. And then multiply. How do we multiply fractions? Straight across. X to the 21 times 1 is x to the 21st. And then these are no like bases, so I'm just going to rearrange them in alphabetical order. Can we simplify anything? The x's are the same base, so we can subtract those and get x to what power? 13th. Does it go on top or bottom? Big kid gets leftovers. And there's my final answer. X to the 13th over 3y to the 3rd. So you go until your bases are all different and your numbers are all simplified as a fraction. Okay, so what's next? Oh, yeah. Lots of parentheses. Two over x squared all cubed times 3x squared over y all cubed. Now, what do y'all think we're going to do? Yes, clear up your parentheses first. So everything gets the outside exponent. If it already has one, you multiply. So that's going to be 2 to, on the first fraction is going to be 2 to what power? 3rd over x to what power? 6 times second fraction, 3 to what power? X to what power? Over y to what power? 3rd. And then you're going to multiply across. If you want to go ahead and do your numbers, that'll save you some writing. So what's 2 to the third power? 8. And what's 3 to the third power? Can y'all tell me what 8 times 27 is? I don't have my calculator. It's how much? 216? So my numbers on top make 216. Do y'all get that? Why it does that? I just evaluated them and then I multiplied them. And so I have 216 x to the 6th power on top over x to the 6 y to the 3rd. They completely cancel out because anything divided by itself equals what? 1, right? So the x's cancel out. And so my final answer is just 216 over y to the 3rd. So if you had the same base with the same exponent on top and bottom of each other, then they just cancel out. Because dividing anything by itself equals 1. Good job. All right, we're almost done with this section. The first one is a 6, the second one's a b. So that's 6a to the 4th, b to the 5th, divided by ab times 2ab over a squared b squared, and all of that fraction is cubed. So the first fraction doesn't have a parentheses, does it? So that one will not change right now. So I'm going to copy it down here. And then the second one, I'm going to give everything a cube. And if it already has an exponent, I multiply times 3. So that's going to be 2 to what power? A to what power? 3rd. B to what power? Over a to the and b to the 6. Now I'm ready to multiply across. When I do, I'm going to put my like stuff together. Are y'all with me? So I'm going to start with my number. This one is 2 to the 3rd power. What is 2 to the 3rd power? Memorize that when we see it a lot. So this is 6 times 8. What is 6 times 8? 48. And then I'm just going to write down my a's together. I have an a to the 4th and an a to the 3rd on top. And then a b to the 5th and a b to the 3rd on top. And on bottom, I have an a to the 1st and an a to the 6th. And a b to the 1st and a b to the 6th. Y'all see what I did? I just rearranged and put my like bases together. So let's clear up that numerator first. What can I do to simplify the numerator? Add my exponents on my a's and add the exponents on my b's, right? So I'm going to get 48 a to the what? 7th and b to the what? 8th. And on the denominator, same thing. Add your a's, add your b's. You'll have a to the what? And b to the what? 7th. And now I can just divide them, right? So, like terms or like bases, what's a to the 7th divided by a to the 7th? 1, they cancel out. They're the same on top and bottom, they cancel out. And then I can subtract my b's, and what do I get? B to the 1st power, on top or bottom? On top. So everything's on top, so my answer is just 48b. So all of that big, ugly problem is simplified to be 48b. Does that make sense? Now, technically, if you skip this writing out step right here, if you had just went ahead and added those and put an a to the 7th here and a b to the 8th right here, I wouldn't fuss at you. Okay? I was just writing it out to show you. You guys try these 3 problems. Simplify them all the way. These are T's. And that's a 16 on the bottom, not a 1B. The first one is a B on the bottom. All right, y'all help me out. What did you get on number 1? Yeah, all you have to do is give everything a square. So it's a squared over b squared. Very good. What do you do first on number 2? So you give everything a square. So it's going to be x to what power? Over 4 to the, and y to the And I guess all you can do is fix the number, right? So what is 4 squared? So I would have got x to the 4th over 16y squared. Who got that? Good job. And what did you do first on number 3? So everything got a third power, so it's going to be 2 to what power? Third. X to what power? Over 3 to what power? And t to what power? And then I multiply across. I'm going to do my numbers first. On top, what do I have? 8. I'm just going to copy my. I didn't put them in alphabetical order. Oh, well. What's 3 to 1? 3 to the third power. What's 27 times 16? 400 and what? Okay, and then I have a t to the third on bottom. Does 8 over 432 reduce? Yeah, how do you do that in your calculator? Top divided by bottom. Top divided by bottom. Math, enter. And I'm getting 1 over 54. Y'all get that? 8 over 432. Math, enter. Did yours get 1 over 54? Okay. So we'll put the 54 on the bottom. Do I have anything that's variables that will subtract? The t's. And I subtract 5 minus 3 and I get what? T second. Does it need to go on top or bottom? Top. Big kid gets leftovers. So those are canceled because that's 1 over 54. X to the 9th stays on top, and then t squared on top. So I'm getting x to the 9th, t squared over 54. Did y'all get that? Yes, ma'am. You can put the 1 on top too. Yes. I'll put it there if I have nothing else to go there. Sometimes I do, sometimes I don't. I'm usually not consistent on that. All right, any questions on any of these? All right, that's the end of section 8.2. We are going to go ahead and do 8.3 today and learn 2 more exponent rules. And y'all start copying while I write these 2 on the board over there so I can have all of them in the same place. So we're going to add 2 more exponent rules in this section. And the first one is the 0 power. Anything raised to a 0 power equals what? 1. Anything raised to a 0 power equals 1. If you don't believe me, type in a number and then rooftop 0 in your calculator, and it will tell you that equals 1. So 2 to the first power equals what? I just said what the answer was. 2 to the 0 power equals what? 1. All right. The next one has a bunch of variables to the 0 power. What do they all equal? 1, because you see how that 0 is on the outside of the parentheses. So that means everything gets the 0 power. And 0 times all those numbers will be 0. So everything to the 0 power equals 1. What about that next one, 2x to the 0y? Does that whole thing equal 1? Just the x part. So the x part equals 1. So it's like saying 2 times 1 times y, which is what? 2y. Does that make sense? So if it's not in parentheses, then you only give that part the 1. Does that make sense? So in this last example, the x is the only thing that was raised to the 0 power, so it's the part that turned into a 1. So that's it for 0 exponents. We might see a few of them built into some more problems. And next, and for the rest of this section, we will be talking about negative exponents. So if we have a negative exponent, y'all, that is not simplified. It is not simplified to have a negative exponent, okay? So the way we get rid of negative exponents is we move the base to the other part of the fraction. Now, what do you think I'm talking about when I say other part of the fraction? Yeah, a numerator will go to the denominator and a denominator will go to the numerator, all right? So we move that base with the x on it to the other part of the fraction, and then we change the sign of the base to a positive, okay? So moving it changes it to a positive. Now, you might be saying, like, problem A is not a fraction. Technically, everything's a fraction. So we can put that over what? 1, okay? So it's in the numerator, right? So what we're going to do is we're going to pull it to the denominator and make it positive. So put a 3 squared on the bottom. Now, can you leave an empty numerator? No. What do we put there? A 1. And then you just evaluate 3 squared. And what's 3 squared? 9. So it's 1/9. Is what that simplifies that. 3 to the negative 2 power simplifies to 1/9. All right, and B, the whole fraction is in parentheses. So what do we have to do if the whole fraction is in parentheses? Yeah, you give everything the negative 2 power, right? So that's going to be 1 to the negative 2 power over 5 to the negative 2 power. And then what do we do with negative exponents? Don't say flip. We're not flipping. Yeah, we move them to the other side of the fraction. This one turns out to be kind of like a reciprocal thing, but we don't want to say that's what you do because it's mathematically not what you do. Because you're not going to move everything every time. Does that make sense? So we're going to move the negative x to the negative 1, or the x, why am I saying x? 1 to the negative 2 exponent to be a 1 squared on the bottom, right? And what are we putting on top? 5 squared, right? And we can simplify those numbers. What's 5 squared? 25. Over what's 1 squared? And what's 25 over 1? 25. We good? Let's go ahead and scroll a little bit so y'all can see what's coming. So I can see what's coming. So the next fraction says 1 over 2 to the negative 3rd. So what do you think we're going to do? So what do we bring to the top? 2 to the 3rd. And it's okay to have an empty denominator. That just means it comes out to be a whole number, right? So what is 2 to the 3rd power? 8. So that one just simplifies to 8. There's 2 ways you can do problem D. About to spill my cough. You see me? I was fast with my left hand. That's amazing. That's a miracle. Miracle. So D, you can think of it 2 different ways. What's one way one of y'all thinks about what to do number D? How? You add them, and you get 6 to what power? 0, which equals what? 1. Or you can do your little moving your exponent thingy for the second one. The top one doesn't go anywhere because it's a positive exponent. But this one goes to the bottom because it's a negative, and then they divide by each other and make 1, right? You don't have to work it both ways, but I'm just showing you can think of it either way. Does that make sense? Either way, I got 1. So if you want to add them, that's fine. If you want to move negatives to the bottom on one like this when they have the same base, that's fine. If they don't have the same base, you'll have to do this. Okay? Look at E. What do you think we're going to do on E? Why are we moving 5 squared? I'm not asking for the answer. What do I do? What do I move? Okay. You only move at negative exponents. Okay? So I'm going to have 1 over 5 squared times 5 to the first, which is what he did. 1 over 5 to the first. Does that make sense? Y'all see that? Negative exponent had to go to the bottom, and then they had the same base down there, so I add them, and we can simplify that further. What is 5 to the third power? So it's 1 over 125. Questions? I'm going to skip these U-tries, and we're going to go to the more difficult stuff. Oh, yeah. Exponent rules are fine. Look at F. It says 5 to the negative third to the negative first. What's going on there? Yeah, they're power of powers, right? So we multiply those, right? So what's negative 3 times negative 1? Positive 3. So this is just 5 to the third power. And what we just did that. What is 5 to the third power? 125. So if you take powers of a power, sometimes it changes your signs, right? And it keeps you from having to deal with negative exponents. Sometimes it does. Not always. So look at G. Parentheses 2xy to the negative fifth, all raised to the third power. So what do we do when we have parentheses? Give everything the outside exponent. So that's going to be 2 to the what? Third. X to the and y to the what? Okay. And I've got 2 things I can fix. First thing I can fix is 2 to the third power. What is 2 to the third power? 8. And what do I do with my negative exponent? Put it on the bottom. So x to the third stays on top, and a y to the 15th goes to the bottom. And do I have anything else I can simplify? No. No like bases, no more numbers. I'm done. Does that make sense to everybody? We only move the one with the negative exponent. Okay, problem H is similar. Parentheses first. So everything on the inside will get a third power, right? It already has a power, we'll multiply. So it's going to be 3 to what power? Third. X to what power? Negative 6. And y to what power? Positive 6. So do we have any negative exponents after that? Yeah, we're going to move the x. So what is 3 to the third power? So 27 and y to the 6 will stay on top, and an x to the 6 goes to the bottom. Does that make sense? Everybody good with that? So parentheses, then move your negative exponents. Okay, so problem I don't have any parentheses, does it? No. So what do we do first if it doesn't have parentheses? No. Move negative. Parentheses, then negative exponents, then everything else. Okay? So first thing I need to do is move my negative exponent. So everything else is staying where it is. 3x stays on top. 9x to the third, y goes, it stays on bottom, and I'm bringing another y to the third to the bottom. Yes. When I add them together, they will be, yes. So does 3/9 reduce to 1/3? Okay. And my x's are being divided, so I do what? Subtract. Now, the reason I say the big kid gets the leftovers, if I subtract top divided by bottom, that would be x to the -2, right? And we'd have to move it to the bottom anyway, right? So the big kid gets leftovers, saves you a step. So you do big minus little and put the answer where the big one was. So what is 3 minus 1 is what? So x squared goes top or bottom? Bottom. That's how I like it. Big kid gets leftovers. And then I add the y's, and I get y to the what? 4. And I have 1 over 3x squared y to the 4th. Any questions about that one? Okay, so yeah, you want to do in that order: parentheses, then negative x. Yeah. 3/9 divided made 1/3. Also, even if I didn't put it up there, I would have to at the end because you can't leave an empty numerator. You can go without a denominator, but you can't go without a numerator. Okay. All right, look at J. J has got parentheses and negative exponents. And a negative number, but the negative number don't bother us because it's not a negative exponent. So the first thing you need to do on J is fix your parentheses, right? So how do we fix our parentheses? Yes. So that's going to be 2 to the -2, x to the -2, and I'm copying everything else. And then what do we look at after we take care of our parentheses? Negative exponents. Do we have anything with negative exponents? What? The 2 and the x on top, right? So those get to move to the bottom. Everything else will stay on the same side of the fraction it's already on. So on the numerator, all I'll have is y to the 5th, right? And I'm going to put everything with its like base. So I have a -4 already on the bottom, and I'm going to bring a 2 squared to the bottom, right? And I already have an x squared on bottom, and I'm bringing another x squared to the bottom, and then I'm keeping a y squared on the bottom. So I only moved the 2 that I highlighted. They had negative exponents, so they both went to the bottom. So I got a few things I can simplify. I can simplify my numbers, I can simplify my x's, and I can simplify my y's. Okay, so let's start with the numbers. What's -4 times 2 squared? Negative 16. Now, y'all, you can put this negative anywhere on the fraction. You can put it in the numerator, denominator, in the front of the whole thing. Okay? That makes sense? And what do I do with my x's down there? How do I combine them? I add them. They're multiplied, so I add them. I get what? X to the fourth, and that stays on bottom because that's where they were. And then what do I do with my y's? Subtract, and what do I get? Y to the third. Top or bottom for y to the third? Why does it go on top? The big kid's on top. Y'all forever remember that. Big kid gets leftovers. All right, any questions on J? All right, y'all look at K. We're almost done. 2 more examples and some you tries, and then he's done. All right, what do we try to clear up first, y'all? Parentheses. So everything on top gets a negative 2 power, and everything on bottom just gets a square. So on top, I'll have 2 to what power? M to what power? Positive 8 over 5 to what power? Second, and M to what power? 6. And then after I do my parentheses, what do I do next? Look for negative exponents. Do we have any negative exponents? Yeah, 2. So what do I do with that 2? Move it to the bottom. So on top, I have M to the 8 by itself, and then I'll have a 2 squared times 5 squared, M to the 6. Let's work on those numbers a little bit. What's 2 squared? What's 5 squared? What's 4 times 25? So 100 on bottom. And what do I do with my M's? Subtract. They're divided, so I subtract. What do I get? M squared top. Big kid gets leftovers. So this is just M squared over 100. We good? Oh, this is so easy, y'all. We've done problems a lot longer than that. Look, same problem. I'm just going straight across. I mean, take up like 4 total lines of paper. 3. Depends on how fat I write. Come on. Do we have any parentheses on L? No. So what do we do? What do we do? You move the negative exponents. What all has a negative exponent? Okay. I highlighted them all, right? So I'm going to move those 3 terms first to the other part of the fraction. Now, this is where it gets confusing. How do you make it not confusing? What are you not? Okay. Is it you don't understand, or is it because it's just stressful because it's tedious?
Yeah, it's stressful. Yeah, I guess that's
okay. But we understand what's going on. Parentheses, and then we move negatives. And then you simplify. Yeah, don't mess up. How do you get good at anything? You practice. You practice. Perfect practice makes perfect. So you got to practice well. You can't just. I'm about to give you a lot of practice. You think I'm kidding? All right. Y'all have got to be able to do this. I'm telling you, I teach algebra too. Exponent rules are very, very, very important. You signed up for Algebra 1. And I'm not even going to say honors because regular Algebra 1 did this 3 weeks ago. I ain't lying. All right. So, everything that's not highlighted will stay in its same location. So, the 2 is going to stay. But I'm going to bring a 4 squared up beside it, right? Right? Okay. N to the 3rd is going to stay. And I'm bringing an N to the 1st up beside it, right? The P's ain't going to change. So now I have M to the 3rd on the bottom, and I'm bringing an M to the 4th down. Does that make sense? So the ones that I move, and it don't matter which order you put them in, as long as they go to the right spot. The ones I highlighted blue are the ones I moved. Does that make sense? It's tedious. I will give you that for it. It's tedious, but it's very important. Yes. It means it's like got tiny little details. It's got tiny little details. That's what it means. My mama uses that word. She don't have no college education. She don't have no. Listen at me. I need to go apologize for this part. Okay. 4 squared is what? Times 2. 32. I can add my ends on top, can't I? N to the 4th on top. I can add my m's on the bottom and get m to the what? And what do I do with my p's? And what do I get? P to the 5th, top or bottom? Big kid gets the leftovers. There we go. It's supposed to be M. It's supposed to be M. See, look. Tedious. Miss Isbell missed the detail. Miss Isbell admits when she's wrong. It rarely happens, but I'll do it. Nope. You can't do it. You'd have. Y'all try this one. You got this. There's not even any parentheses. You just gotta move the names. All right, so which one did you move? All right, the y on top and the x on bottom get moved, right? So, y'all helping me or what? Okay. So, everything else besides the two I just circled are moving or staying put. Those two are moving to the other side of the fraction. So, on top, I'll still have a 6 and an x to the third, and I'm bringing up an x squared, right? And then I have an n to the fifth on top. And on bottom, I have a 9. I'm bringing down a y to the fourth, and I have a y to the seventh and an n to the third. Right? And it don't matter if you have these in a different order. Okay? It don't matter. Because it'll simplify the same. The 6/9 simplify as a fraction. 2/3. Good. What about your x's on top? What do you do with those? Add and get x to the what? And same thing with the y's on bottom. You can add those and get y to the what? And what about those n's? Subtract them and what do you get? N squared on top, because that's where the big one was. Raise your hand if you got that for your answer. And y'all are so smart. How are we going to get good at it?